For this example, we need to describe the transformation and do the graph. We also need to identify the domain and range. If I take a look at letter A here, I see that this is a square root function. So if we're going to use transformations, we should know what the parent function looks like and then identify what the changes are between that equation and this one. The parent function equation for the square root graphs would be y is equal to the square root of x. It's the most basic equation that we can have involving x and y and a square root. And if we went through and made an xy table and plugged in some numbers for x that gave us nice integer values, we would end up with these 3 points here. 0, 0, we have kind of our starting point here, and then 1, 1, and then 4, 2. And then from there, we could draw in the shape of our graph. It starts here at 0, 0 and has kind of this gentle curve. As this goes to the right, it will continue to go upward. It starts out kind of steep, and then as we go to the right, it gets less and less steep. So with that in mind, we should be able to compare that to this equation, identify our transformations, and do our graph. So taking a look at what's here, when I look at our function here, the things that I see that are different is out here after the square root, we have a -1, and then there's also a negative symbol in front of the square root. So that'll give us two different transformations. Anytime we have addition or subtraction, we're going to be sliding our graph upward or downward or left or right. This one happens to be vertical shift. If you have addition or subtraction after the square root, not inside of it, then it's vertical shift. Pluses up and minuses down. So this would shift our parent function graph that we just took a look at down 1 unit. There's also a negative symbol in front of our square root. And if there is a negative symbol in front of our square root, what that's going to do is that's going to give us a reflection. Specifically, it's a reflection over the x-axis. So the first part of the directions are to describe the transformations. I've done that. You need a couple of phrases that describe how this graph is going to differ from the parent function. And then from there, you want to draw the graph. The parent function graph that we looked at has these 3 points, 0, 0, 1, 1, and 4, 2. When you do a reflection and you do a translation, either vertical or horizontal, we want to do the reflection first and then do the slide. So I'm going to do this as a series of a couple of different graphs. So first off, here is our parent function graph. That goes through the point 0, 0, through the point 1, 1, and through the point 4, 2. This is the equation y is equal to the square root of x. That's our parent function graph. What I'm going to do in my next step is I'm going to do our reflection next. So I want to take this graph and I want to do a reflection over the x-axis. So we have our 3 points up here. This point is 2 units above the axis. So if you reflect it over the x-axis, that would be 2 units below. So this point would get reflected down here. This is 1 unit above. It would get reflected 1 unit below, and then our point at 0, 0, the distance there away from the x-axis is 0. So you end up with a graph when you do a reflection that looks like this. So this is what the graph of our parent function graph would be, but with a reflection. And now what I need to do with that is I need to take that graph, the one that I have in red, and I need to slide that down 1 unit, and that will give me my final answer. So if I take a look at this graph here, we have 0, 0, we have 1, negative 1, and we have 4, 2. I want to slide all of those down 1 unit, and that will give us our final graph. If I take 4, negative 2, which would be right here, and slide that down 1 unit, we would be at the point 4, negative 3. If I take 1, negative 1, which would be right here, and I slide that down 1 unit, that would be the point 1, negative 2. And if I take 0, 0, slide that down 1 unit, that would be the point 0, negative 1. And our graph would look something like that. So this is our graph for this function. This is our final answer. What we have up here in this graph is our work. We have our parent function graph. We did our reflection over the x-axis, and then we moved it down 1. That gave us our final answer. So in the directions, we want to describe the transformation. Did that. It's a reflection over the x-axis and move that down 1 unit. We wanted to go through and graph the function. I did it using transformations. Another option would be for you to make an XY table from this original equation. The last thing I need to do is identify the domain and the range. The domain is how far to the left and how far to the right our graph goes. Our graph goes over to the left here. This is the leftmost point, and the x-coordinate there is 0. And this graph goes forever to the right. So the domain is going to be from 0, including 0, to infinity. Our range, those are our y values. That's the height of our graph. I want to take a look at how far up and how far down our graph goes. The highest point is here, and the height of that point is negative 1. The lowest point, well, this graph is going to go down for forever, down to negative infinity. It'll go very, very slowly, but it doesn't ever level off. It continues going to the right and down, to the right and down, to the right and down. When we do our interval notation, I do want to include the lowest number before the comma and the largest number after. So the lowest number actually would be negative infinity in this case, and it goes up to a height of negative 1.